This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2017 AP Calculus exam free response question BC5. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I am a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question and the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question. And then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some specific scoring examples. In this problem, we're given a rational function f. In part A, we need to find the slope of the line tangent to the graph of f at x equals 3. In part B, we need to find all the critical points of f in the interval 1 to 2.5, and then classify each of these as the location of a relative minimum, relative maximum, or neither. In part C, students were asked to use the partial fraction decomposition of the function f to evaluate an improper integral. And in part D, students were asked to determine whether a related series converges or diverges. Part A was worth 2 points for finding the value of the derivative of f at x equals 3. Part B was worth 2 points. 1 point for finding the x-coordinate of the only critical point in the interval 1 to 2.5, and 1 point for stating that this is the location of a relative maximum with appropriate justification. Part C was worth 3 points. 1 point for finding an antiderivative, 1 point for using a limit expression appropriately, and 1 point for finding the final answer. Part D was worth 2 points for determining the correct conclusion that the series converges, and for stating the conditions necessary to apply an appropriate test for convergence or divergence. Here are some brief comments about student performance on this question. In Part A, most students were successful in using the quotient rule and the chain rule, and making the connection between the derivative and the slope of a tangent line. However, there were some presentation, linkage, and algebra errors. Some students dropped the negative sign in the derivative, and there were attempts to differentiate the partial fraction decomposition given in Part C. In Part B, most students were able to identify the potential critical points. However, some had difficulty with justifications, using vague language. In addition, some students didn't know how to deal with x equals 1 and x equals 5 halves. In Part C, most students seemed to convey a conceptual understanding of this improper integral. However, some students lacked good communication skills and/or proper notation. There were instances of missing limit notation, improper use of the properties of logarithms, and arithmetic with infinity. Most students were able to find an antiderivative. In Part D, most students conveyed a conceptual understanding of the integral test or the limit comparison test, but few were able to state the conditions necessary to use these tests. Some students used inconsistent notation or language. Some students were unable to select an appropriate test for convergence or divergence, and many of these used very informal approaches. Part A was worth 2 points for finding f prime of 3, but it was possible for a student to earn only one of these 2 points, and here are some examples. The student presents a correct expression for f prime of x with an incorrect value of f prime of 3. The student could convey a conceptual understanding of the chain rule, but in this form, and earn 1 point. If there was a missing square in the denominator of f prime of x, but this expression was evaluated correctly at x equal to 3, the student would earn 1 point. And there were some special 1-point cases in which students presented an equation of the tangent line as their final answer, or they linked unequal expressions with equal signs, called linkage errors. The first point in Part B was for identifying the x-coordinate of the only critical point in the interval 1 to 2.5, that is, for x equals 7/4. The student could also earn this point if they are consistent with an eligible 1-point form imported from Part A. So recall, each of these expressions for f prime of x earned 1 point in Part A. In the first case, the student would have to identify minus b divided by a, and this value would have to be in the interval 1 to 2.5. And in the second case, the x-coordinate is 7/4. The second point in Part B was for classifying the critical point as a relative maximum and for providing appropriate justification. The student must explicitly state that there is a relative maximum at x equals 7/4. And here are some acceptable justifications. Remember that a sign chart is not sufficient justification, and the student doesn't need to provide a value of f double prime of 7/4. Justification points often take some extra time to read in order to score properly. Here are some statements that do not earn the justification point. And let me see if I can explain why each of these statements is not acceptable. In the first one, this is a general definition of a relative maximum, and the justification is not in terms of our problem. In the second one, we don't know what slope the student is referring to. The slope of what? And in the third, there's a similar issue. The derivative of what? Other incorrect or vague statements like these often involve the following. F prime is increasing or decreasing. The slope or the derivative of f prime of x. Inappropriate pronouns. And as we saw up above, statements that include the slope or the derivative without specific references. Here are just a few final notes associated with scoring Part B. Readers had a very precise method for dealing with students who also identified x equal 1 and or x equal 5/2, even though these values were not in the interval. It was possible for a student with an incorrect expression for f prime of x, but an eligible form, to still earn both points in Part B. And in fact, there were some common incorrect forms that led to a relative minimum, which was the correct conclusion for that incorrect form. The first point in Part C was for the correct antiderivative. This point was earned for the correct antiderivative only, and both parts must be correct. The absolute value symbols are not necessary here. They can be present, but they aren't necessary since x is greater than or equal to 5. And if the student incorrectly reported the first part of the antiderivative as 2 times the log of 2x minus 5, they did not earn the first point. They are eligible for the second point, and they do not or cannot earn the third point. The second point in Part C was for appropriate use of the limit expression. And this is earned when the student uses the limit as b goes to infinity correctly, that is, attached to the definite integral or an antiderivative. And here are the two general statements that would earn this limit expression point. To earn this point, the student must use proper notation, and the student could use wandering or late limit expression in order to earn this point. The third point in Part C is the answer point, and this is earned for our answer only. There was an eligibility criteria here. The student must have the correct limit notation attached to an antiderivative. Note that the correct solution can be presented in several different forms here, using properties of logarithms. And some students made a common copy error. They changed the subtraction symbol to an addition symbol at some place in the integrand. Now, in this case, the student loses the first point. It's a copy error, but they're eligible for the second and the third. However, in some cases, in some changes, the integral does not converge. And in that case, the student cannot earn the third point. Part D was worth 2 points. For the answer, the series converges, and the appropriate test conditions. Students may use any of these tests for convergence or divergence here. The integral test, the limit comparison test, or the direct comparison test. The ratio test is inconclusive here. Now, some students tried one test and abandoned their work and tried another test. And in this case, this was treated as a restart and not parallel solutions. So here's the general philosophy used in scoring this part. In general, the student earned 1 point by correctly executing one of these tests and for drawing a correct or a consistent conclusion. Some notational issues and the test conditions were considered as part of the other point. The sequence of questions in this problem, I think, should have led students to the integral test. Therefore, in using the integral test, the student must either refer to Part C or restate the integral from Part C. And the conclusion must be consistent with their conclusion from Part C. So, the student may conclude that the integral in Part C diverges and still be eligible for both points in Part D. To earn the conditions piece of the 2 points in Part D, the student must state that the function f, the integrand, is continuous, positive, and decreasing. Now, the student doesn't have to explicitly state the interval 5 to infinity, but if they do present an interval, it must be valid, and that is the conditions on f must be true. And the student must state these conditions about the function f, not about the series. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There's material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.